In this video, I'm going to show you how to solve some exponential equations. Some of these may have the same basis, some of them may be different. When they have the same base, or can become the same base, let's do that. 81, we know that is 3 to the 4th power. Now that the bases are the same, they become unimportant to the problem. I'm going to subtract my 2 over, and I'm just going to do a simple sign change. The domain for exponential graphs is all real, so there's no reason why that wouldn't check. Here I have 4, 16, 68, 8. They're all 2s. No reason to multiply those together. 4 is 2 squared. 16 is 2 to the 4th. 64 is 2 to the 6th. And 8. Now that the bases are the same, I can get rid of the bases. Now, because I have all these different twos, you were taught to add bases or add the powers. You could have done that in one step. You didn't have to show me all that. 2 plus 4 plus 6 plus 3. I'm going to add the 3, divide the 6. 2. 16 and 1/8, these are 2 numbers. 16 is 2 to the 4th. And 8 is 2 cubed, and the 1/8 would be the negative 3 power. Bases are the same. I'm going to subtract the 4 and divide out the 8. 8 to the x is equal to 1. Well, that can only happen if x is 0. Anything to the 0 power except for 0 will give you a 1. You commit that to memory. (125), 25, and 5. These are 5 numbers. 125 is 5 cubed. I still have the other power, and I'm going to write it in a way that I remember to multiply those. 25, and 5 to the square root of 5 is the 1/2 power. I can get rid of my 5s now. On the right-hand side, I'm going to add those 2 powers. Okay, before I take care of the fraction, I'm going to distribute the 3 there. Now I'm going to get rid of the 2. This will become 12x. I'm multiplying everything by 2. Four and 1 make 5. I'm going to add the 24 to it. That gives me 29. And then I'll divide out the 12. This problem here is different. Here's how I would do this. I'm going to get rid of the 6. I'm going to get rid of the 2. So I subtracted the 6. I'm dividing the 2. And if I want to get this x here by itself, what I'm going to do is I'm going to reciprocate. I'm going to reciprocate that power. So x is equal to the 5 halves. And when I reciprocate, I also get the 5 halves as a power. As far as that can go. 21, we have numbers here that are 3s. 27 is 3 cubed. 81 is 3 to the 4th. Don't forget your x. Bases are all the same. Over here on the left-hand side, I'm going to add these 2 powers. 2 and 3 on the same side is a 5. I'm going to add that x over and divide out the 5. Here we don't have bases that are the same. First thing I want you to do here is I want you to get rid of the 2 so you can isolate the term, the part that has the exponent. I'm going to throw logarithms at the 2 sides, but because I'm dealing with the e, I'm going to throw natural logs at the 2 sides. That allows me to pull the power out front. And because I know the natural log of e is 1, then that just simplifies to an x.